acceleration for t is greater than or equal to 0 is given by a of t equals t plus 3
Oh,
over
not
the
this one.
square root of t cubed plus 1. Particle velocity at t equals 0 is 5. What is the particle velocity of the particle at t equals 3?
Okay, so we're going to find the velocity by the following. If y'all remember PVA. So if f, or if the derivative of f is f prime, then derivative of v is a, correct? Okay, so using that formula, I'm going to use the integral from 0 to 3. And I'm using 0 because they gave us the initial value. Always use the initial value. In this case, we have a of t. Oh, should be dt. Oh. Is equal to v of 3 minus v of 0. And then if I were to, since we're looking for v of 3, let's go ahead and move this guy over. So I'm just going to leave v of 3 on the other side over here, but really in the end I'm adding on to. We have plus the integral a of t dt. From here, it's simply going to be our calculator portion. So on our calc, Andrew, what is given to us on v of 0 already? All that is going to be replaced with what number? When t equals 0?
Yep.
5. And then we have plus. Where do I get the integral? Math number what?
9.
Good. Now go to math 9. And we're all typing together. I don't want you to freeze about the calculator when you get to the AP test. And then we're going to type that in exactly we see except with the variable x. So here's my alpha y equals x plus 3. On the bottom I have square root of x cubed and then plus 1 and dx. Let's double check. Okay, mine's good. Okay, Lawrence, go ahead and press enter and tell me what number you get.
11.7.
Boom. Freebie, right? Don't miss that one. Okay, next one, we got 90. Okay, Abby, let's read number 90, please.
Let f be a function such that from 6 to 12, f of 2x dx equals 10, which of the following must be true?
Okay, so when you're looking at this, you might be going, well, f of 2x, they didn't even give you the function at all. So the best thing for you to do is analyze the answer choices. So I have it in terms of x, but all of a sudden my answer choice has what? In terms of what letter?
T.
So I need to transform it. So that will be our u substitution. So let's recall. T is equal to 2x. dt is equal to 2 dx. And we want dx by itself because I have dx right here by itself. 1/2 dt is equal to dx. And then when I do my direct substitution, I'm going to kick out the 1/2, write the integral, f of t dt is equal to 10. One thing that I'm missing, I did not add the lower bound and upper bound yet because we're converting everything in terms of t. So right now, when x equals 12 versus when x equals 6, we're plugging that into 2x right here. So Ian, when I plug in the 12 into t equals 2x, who is my new t value?
24.
24. And then Abby, when I plug in the 6 into 2x, what's our new t value? Plug this one in, into the x. 12 it is. And if you look at your answer choices, does that exist? Do we have that anywhere on the answer choice?
No.
So clever. They got rid of this fraction, so let's think about balancing it. What would I multiply the whole thing by to get rid of 1/2, Andrew?
2.
2. And when I do, that goes away, and I have all this remaining, but instead of 10, I'm going to get what? 20. Now the answer choice is what? B it is. So that one was a little bit tricky, okay? But it wasn't hard to get to. Okay, 91. Lawrence, let's read that one.
Let f be a polynomial function with values of f prime of x at selected values of x given in the table above. Which of the following must be true for -2 is less than x is less than 6?
Okay, so when I get to a question like this, I'm going to automatically go to the answer choices. We're looking at concavity. Point of inflection is also concavity, increasing, no critical point, and so on. So we have to go all the way to second derivative, okay? So let's see if we kind of remember. If I find the slope between these two numbers, aren't I looking for f double prime then? F double prime, because slope is the derivative. So let's do a quick number between these two numbers right here. I'm going to do y1 minus y2 divided by x2 minus x1. Are you guys okay with where I'm getting the plus 2 from? Plus the negative? All that is going to give me a positive or negative. Because I don't care about the actual number.
Negative?
It is negative, so we know. This one is negative, meaning the point, the concavity is concave down between these 2 points. Now let's find the slope between this one. We have y2 is 4 minus y1 over x2 minus x1. All that is going to give us what? Positive. So I'm going to say concave up. Okay, let's do it again. Between 4 to 7. y2 minus y1 over x2 minus x1. That's going to give us positive or negative?
Positive.
Positive again, so let's kind of write on here. We had a negative, we had a positive, and another positive. And then let's go on to the next one while we're at it. 5 minus 7 over 6 minus 5. That's going to give us positive or negative? Negative, so we know it's going to be concave down. Okay, let's see what's happening. And I should put concave up here. Point of inflection, if you look at your flashcard number 5B, happens when we're changing concavity. So let's see where we are changing concavity. Down and up, that's POI right here, point of inflection. If it's up to up, am I changing concavity here?
No.
Nope. And then we have up to down, we have point of inflection. So how many points of inflections do I have here? Is that an answer choice, first of all?
Yes.
There's at least 2. And once you get to it, you don't have to go on any further. Okay? Y'all good with that? All right. Our last one. Okay, Andrew, let's read that one. 91 or 92.
Let R be the region in the first quadrant bounded below by the graph of y equals x squared, and above by the graph of y equals x. What's that called again?
Square root.
Square root. R is the base of the solid whose cross section is perpendicular to the x-axis. X-axis are squares. What is the volume of the solid?
Okay, let's underline perpendicular to the x-axis, and I want you to write with respect to x. That means it's top minus the bottom. So I'm going to model. If I do top minus the bottom, aren't I scanning from left to right? Yeah? So we have, and it's a square, so that's going to be side squared. So here I go. You can choose to graph this on your graphing calculator or automatically know that we have a parabola intersected by our square root. It's going to be this guy over here. So that means we have, and the intersection is 1, and if you don't know that it's 1, can you use second calc, intersect, and so on? Yes, you can. So we have, let's make our vertical right there. It's top minus the bottom. The top was a square root function. The bottom was a square function. So here I have our volume is equal to the integral from 0 to 1. My top function is square root of x minus x squared. And it says all squared, wrap it up, dx. And we're going to actually type this in together. Keep in mind, your calculator is going to automatically pre-populate that many parentheses, so make sure you mimic this. So here we go. My last one, we're all typing. Math 9 on the home screen. From 0 to 1. Oh. And then open up another parentheses, just like I have on my paper. Square root of x minus x squared. And then close it. And after I close it, the first parentheses is going to close that one, okay? And then I need all squared. Okay. Oh, why is it on x? Should be x. So let's double check. I have 1 and 2 closed parentheses. I should have 1, 2 open parentheses. Do count that on your calculator. Okay, when I press enter, Andrew, what's the answer
Wait,
choice?
don't pick on me. Wait, hold on.
Type it in.
No, I got really lost. Like I'm
You did not get lost by
Yeah.
typing. You want me to type it one more time?
no, just ask somebody else. Fair enough.
Okay.
I read the question.
All right. Abby, which one is it?
129.
What was that?
0.129.
Oh, okay. 0.129. And I'm going to press enter just to show you.